let's take this one step further. So we have our three-dimensional surface. We really don't have much of an idea what it looks like. This one might be a sort of interesting study in domain, but it would be a three-dimensional domain, not a two-dimensional domain. So let's just continue with what we had before. We have this three-dimensional surface. We can't actually see it. That's kind of the point of calculus, to study things that we can't necessarily see and measure exactly by sight. We take this gradient calculation, which we did before, and if we apply this gradient calculation to a particular set of coordinates that is on the surface, this particular vector that we end up with right here, that vector is normal vector at the point -2, 0, -1. Okay. So we had two follow-up questions given this information. The first follow-up information was, what is the equation of the tangent plane? Equation of the tangent plane. And to write the equation of a tangent plane, it was of the form ax minus x naught b y minus y naught c z minus z naught equals 0. Once upon a time there was a dot product in there equal to 0, which meant the vector ABC was orthogonal to any vector that was on the plane itself, given a point on the plane. So now the plane we're looking at is tangent to this strange 3D surface. Well, we know the vector, -8, -9, and +1. We were also given coordinates when this problem began. -2, so that'd be x minus -2 is x plus 2. Y is 0, y minus 0. Do I need to write the 0? No, but I'm choosing to make sure you know that it was done intentionally. Z minus a -1 would be z plus 1. That is the plane tangent to the surface. Another side question we could ask is, what are the parametric equations of the line that's normal to the surface? There is one question. Here's the other question. So the parametric equations of that normal line use similar information to the plane, but displayed much differently. You have a place to begin, and I'm not writing down the basics again because this is something we've done many times. The starting point is the point where it's tangent to the plane, since that's the only point given to us. -2, 0, -1. We probably could find other points in this line, but that would take a little additional labor. And I'm going to just go with it that maybe we don't want to do extra work. And this line, so let me just do imagination here. If the surface was our parabolable, and there's a point in the surface, I want the equation of that line. I just need the direction that line goes. Well, its direction vector is -8, -9, and +1. And these, my students, are the parametric equations of the normal line. Now, before you go to the next video, you should try to do section 13.7, number 12, which is very similar to this problem. This one, I will put solutions into Canvas so that you can see them. All right, here we go.